All right, the last extra examples I'll do for you here in section 6.1 involve determining the inverse of functions. And there's a very important piece of information that I need to let you know. And that's the following. Any logarithm can be rewritten as an exponential. Any exponential can be rewritten as a logarithm. We're going to use that fact to help us find the inverse of functions involving exponentials and logarithms. Well, we're going to start by using the strategy we learned last chapter, which is to find the inverse of a function. We need to switch the x and the y. So I'm going to write this as x equals 4 raised to the y plus 3 power minus 12. And the thing we learned last semester was that our goal needs to be, we need to solve for y. So I'm going to start by getting rid of this negative 12 on the right hand side, and I'm going to add 12 to both sides. So I have x plus 12 equals 4 raised to the y plus 3 power. So right now I'm kind of stuck because the y is contained up in that exponent there, and I'm not sure how to isolate it unless I go back to the idea up at the top of the paper here, where it says if b to the c equals a, I can rewrite that as log base b of a equals c. So I am now going to rewrite this equation as a logarithm instead of as an exponential. So the log base 4 of x plus 12 equals y plus 3. And I'm just going to repeat something I've said previously. Remember, the log base 4 of x plus 12 equals y plus 3 means that 4 with an exponent of y plus 3 equals x plus 12. And that's what we have over here. 4 with an exponent of y plus 3 equals x plus 12. Well, we're not quite done yet because now we need to solve for y. And we can solve for y by subtracting 3 from both sides. My final answer is y equals log base 4 of x plus 12 minus 3. And that's the inverse of y equals 4 to the x plus 3 minus 12. All right, next example I'll do here is one that involves the inverse of a logarithmic function. And this one I think is significantly easier than the previous one. Remember, our first step for finding inverses is to switch the x and the y. So I'm going to have x equals log base 2 of y plus 5. And now that I've done that, I need to say figure out what my strategy should be. I'm going to scroll back to the top of the paper where I have this statement right here. If I have the log base b of a equals c, I can rewrite that as b to the c equals a. So, another way to say the same thing, log base 2 of y plus 5 equals x means that 2 to the x power equals y plus 5. Now to solve for y, I simply subtract 5 from both sides and I get y equals 2 to the x minus 5. For these last two examples, I would encourage you to graph the original function and then graph the inverse and make sure you see that they are a reflection across the line y equals x.